Great, thank you very much. Okay, session one, we're having a look at the impact of the global health crisis on energy use data collection. Interesting question, and we're going to have some very interesting discussions about this. First up is my colleague, Monica Forgo, energy use in the commercial institutional building sector in Canada. Monica, are you good to go?
Yes.
Okay, please go ahead. Thank you.
Good morning, everyone. Welcome, everybody from Canada. So I'm the first speaker, and I have to get used to speaking to a screen. It's our new reality, I think. So my presentation is about energy use in the commercial institutional building sector in Canada. And I will go through a bit on how we collect data and how we do our calculation on energy use, how the sector looks like in Canada, and at the end I'm going to talk about how we estimated the impact of COVID-19 on the energy use in this sector. I got very strict instruction to be mindful of the time, so maybe it's gonna look a bit rushed, but I think there will be time to ask questions, and there will be some time to for discussion as well. So first of all, we get our data from Statistics Canada annually. So the demand side is getting data annually, and it's coming through the Report on Energy Supply and Demand in Canada, which is our main source of data. And it gives us the energy use by final consumers, by province, and by fuel type. We do the analysis for multiple sectors: commercial and institutional, residential, transportation, industrial, and agricultural sector. And but today I'm going to focus on the commercial and institutional building sector. So when we receive the data, we have our own end-use model, which was developed for the Office of Energy Efficiency to do modeling on energy use in all sectors. This model is very specific to this use. It uses a bottom-up approach, and it's a dynamic model. It helps us to estimate energy use in the sector, and the data we have is on floor space, and we get some weather data and other surveys what we use. For example, there's a very important survey for this sector. It's the survey for commercial and institutional energy use, which happens every 4 or 5 years in Canada. And it just happened that the data collection is in this year. So of course there was impact on the data collection, and my colleague will talk about it later, Peter Greenberg, how the COVID impacted data collection for this survey. Our data is reported by the North American Industry Classification System, and by activity type, by end use, and by breakdown by activity type, end use, and fuel type within each category. So based or using this data, we calculate energy efficiency trends for Canada. We did calculate the trend from 1990, that was our base year. And this year we are moving to 2000, and just to be more up to date and provide more or later information to senior management and policymakers. So we publish the energy efficiency trend, digital trend online. You can check the Natural Resources Canada website. And also very detailed data is published online. It's the National Energy Use Database, which shows our results on energy use for all sectors. Just to go through quickly what activity types we use here. So the major ones are the wholesale trade, retail trade, transportation, warehousing, office buildings, educational services such as schools and universities, healthcare, and social assistance buildings. So these are the activity types we have data for, and also by end uses, so space heating, water heating, auxiliary equipment, and as well as fuel types. So for example, we have data for the wholesale trade, how much space heating, how much energy space heating is uses, and by what fuel type. So we have very detailed data what we work with. So based on our data, I'm gonna move on to slide 4, please. I'm gonna talk about a little bit of the sector in Canada. So this slide shows that the secondary energy use in the commercial institutional sector is 11% of the total energy use. The highest is industry, followed by transportation, residential, and then the commercial sector. Next slide, please. Oh, go back to slide 5, yes. So this slide shows the key drivers for the sector. And it gives a good picture of our sector, the size of our sector, and how much it grew since 1990 to 2017. So basically, we can say the main driver is floor space and the electronic equipment. As you can see, in the past 27 years, the electronic equipment energy use tripled. So it actually really nicely highlights how important it is to introduce energy use standards for these equipments and use different labels such as Energy Star to try to save energy in equipment. Next slide. So as I mentioned, Canada just moving to a new baseline this year. So from now on, our new baseline it's 2000. We are just updating our database, so we have 2018 numbers as well for certain areas. So this slide shows nicely how much the energy use increased in the past 18 years. It increased almost 20%, floor space increased 26%, employees employed in this sector 34%, and the sector's contribution to GDP is 55%. Basically, the main trend or main result of the trend is the energy use by equipment is really growing, as I mentioned before. Many new equipments are used in offices and hospitals. So it's very important to pay attention to the energy use of equipment. Next slide shows that in Canada, the main building type is the offices. I mean, main energy user is the office buildings. It consumes 35% of the total energy use in this sector, and followed by retail and healthcare. And also healthcare and the accommodation food services are the most energy intensive types in the commercial sector. As I mentioned earlier, equipment shows a 54% increase in energy use in the last 18 years. And it increases the most within the different type of energy use. But still in Canada, the main area is the space heating, which takes up most of the energy use, and just before the equipment, and then lighting. Next slide, please. We also calculate the energy efficiency effect for all sectors. This slide shows how we calculate the energy efficiency effect for the commercial sector. So basically, the fact we have the energy use data for the sector, and we adjust it with different factors. For example, the activity effect. In this sector, for example, the increase in floor space was 26%, which led to 230 petajoule growth in energy use and 9.7 megaton increase in GHG emissions. Also, we take into consideration the weather effect, global warming, it changes, so we adjust the numbers, as well structure effect. In this sector, we notice the relative shift to more energy intensive activities in health services, accommodation services, less extent in educational services. So we adjust the number. Also, we take into consideration the service level effect and other effects. And then our calculations shows the energy efficiency effect, which means that in this sector, resulting from energy efficiency measures, the energy is used 15% more efficiently. If you look at this trend, you can notice that the two lines actually overlap in the early 2000s. That's in real life, it's not really overlapping, but there was some improvement in the data in the meantime, and Statistics Canada had to do some backcasting, and so the data is not perfect. We are still working on it, and as you know, data is never perfect. So we continuously work with Statistics Canada to improve data quality and data availability. On the next slide, I just would like to show you the energy intensity indicators we use. Since we have data on floor space, we can show you the trend based on energy use per square meter. It decreased by 12% in the last 17 years, and energy intensity based on GDP decreased by about 25%. Now, a little bit of COVID-19 impact on energy use. So as I mentioned before, we get our data annually, and we are usually behind by 2 years on our analysis. So, and COVID just happened this year. So basically, we tried to estimate the impact on the energy use in the different sectors. And we did a short paper on it. But I have to say that it's really an estimate. We won't have data for 2 years to validate our estimation. So we used 4 recovery scenarios, various assumptions, and it's a very simple model. We didn't use our highly sophisticated what-if software. And also we had to rely on both official and unofficial information, different announcements, news, and on, for example, what closed, what not. In Canada, all schools were closed, for example, in the spring, so energy use was 0 there. So we could use this information to estimate the impact. And it was our best analysis and guess. So just to go into some details, we estimated the wholesale trade at 30%, retail trade as well. As I mentioned, education, recreation facilities were 0%, they were all closed. Healthcare and social assistance, we estimated an increase in energy use to 150%, food services down to 50%. This was our best estimation. So as I mentioned, we looked at 4 scenarios. The V-shape, basically, we estimated that there will be a lockdown and then everything goes back to normal pretty fast. There will be some stimulus packages, increasing activity. We looked at a U-shaped recession, a longer period between the decline and recovery. Consumers might not be ready to start spending very fast. Many businesses were still closed or even bankrupt, so recovery would take longer. We looked at the L-shaped recession scenario, which is a more extended downturn, and the W-shaped recession, which is a quick recovery and a second decline and recovery again. And now this estimation happened in the spring. We did it in April, June. We revisited it in the summer. So by now we know that Canada is in the W shape. But the first slide in the COVID impact shows what would have happened if we were into the V scenario. So it shows that the impact would have been around 10% on the commercial institutional sector, and same on the GHG emission. If we look at the next scenario, which is an L-shape, it's a longer recovery scenario, the impact would have been much bigger in the sector, 45%, both on energy use and GHG emission.
Monica, sorry to interrupt, just a few minutes to conclude, please.
Yes. So let's jump to the last slide, which is the W shape scenario. So we looked at this scenario as well, and it seems that what is happening in Canada. So there was a coronavirus outbreak peak in late April, early May, and then we started to recover in the summer, and now we are in the second wave. The impact is estimated about 24% in energy use decline in energy use, and about 25% in GHG emission in the commercial and institutional sector. So basically, what I would like to highlight is these numbers are really estimation, and we can validate only maybe a year, maybe 2 years later if we were right. But I trust my colleagues, and I'm sure they did their best using the best available information to estimate the impact. Thank you very much.
Great. Thank you, Monica. Hang on a sec. My apologies, I was pushing the wrong buttons. Thank you very much. We'll hold questions until the end. Next up, we will have Giovanni Perella, who will be talking about weekly electricity consumption index for the monitoring of the main industrial sectors in Italy. Giovanni, are you good to go?
Yeah, thanks, Bob. Thanks, Nick, for the invitation. I would just take this opportunity to share with you what we have done during the last pandemic. As you know, we will try to use electricity consumption recorded by our TSO of electricity, that is named Terna, as the litmus test of the Italian economy during and after the pandemic, the coronavirus pandemic. You know that Italy was strongly affected by the pandemic, that like a tsunami overwhelming everyone and everything. All the hospitals were overrun and lockdown was in place, and just in that situation, politicians asked to statisticians such indicators for the monitoring of the situation. And so in this situation, we think that we could use the electricity consumption for better understand what is happening and as a forecast for what will happen next. And you know that change in electricity demand often is a mirror of the change in the gross domestic production of a country. And so we think that the analysis of the industrial electricity consumption is a good way for better understand the difficulties that the country are living in that moment, and in particular the main sectors of the industrial sector are facing. Next slide, yes. So using the data of this privileged observation point that Terna have, we was just in position to have the monitoring every day of the consumption of a special group of customers, of 530 energy intensive customers that was directly connected to the grids of Terna that have the responsibility of these measurements. And this number of industry altogether represent around 25% of the total electricity used in the industry sector in Italy. So it's a big sample, a very representative sample of the consumption of electricity. So we have reclassified this industry and aggregate by the code of ATECO, and we elaborated the data for the 6 statistically more significant aggregates. That was buildings, materials, steel, chemistry, mechanics, transport, and non-ferrous metals. And what we do was we build an index, a dimensionless index that was pointed as 100 on the first week of February 2020. And just from this point, that it was the beginning of the pandemic, we will try to measure what is happening week after week. And the variation was highlighted to the last week on the previous week or versus the same week of the previous year. And so you can see that this is the complete index. They show that April was the worst month, with a drop of more than 70% compared to the same month of the previous year. And this figure is more or less similar to what was recorded in France, on Spain, and a little bit more in Germany. The figures that are highlighted in this in the paragraph in this slides are referred to the week of 3 October, so it's two weeks before, and you can see it's just for show how is function this index, and it's very simple to present and to understood for the politicians too, because this index was built just for to be used by the politicians and the general director for understand very rapidly what are happening. And so there is the percentage plus 1% is the consumption registered in the first week of October respect the second week, the third week of October respect to the second week of October, and the indication of minus 3% is meaning that the 30th week of October compared to the same week of the 2019 show a declining of 3%, so around less 17 gigawatt hour. Taking a look at the specific sectors, you can see, for example, the huge decline that we had in the steel industry, and that was very, very much affected. While if you take a look at the chemical sector, you can see that the declining during the pandemic period of March and April was a little bit not so strong, as just because in this sector of chemical is included the pharmaceutical industry that had an increase in the production and the request of pharmacs to be used by the populations. And if you go to this next slide, if you take a look at building materials, you can see that was very, very much affected by this lockdown and this situation during the month of March and April, and the consumption of electricity dropping in April by 86%. So very, very big impact. And just now in the months of September and October, it tried to start again with the function of a new measure of a super bonus that try to push the new activity on the construction. What can we share? What was why we think that this is important to share with you? Because this weekly index was very well appreciated from the politicians and the techniques of the ministries that have in charge the monitoring of the economic activity, and then can have an objective monitoring, not only subjective, not only, but they have numbers that say explicitly which are the sector much more impacted by the situation, by the crisis, and where is more necessary to take measure. So it's a good instrument to monitoring the situation in real time, just because the timing of distance from the situation is just 1 week after, and so week after week we can monitoring the situation, and it's very useful for the discrimination of the financial help that the politician and the government have to decide where is the area of the economy that is much more suffering the crisis loss of production, and so it's useful for take decision. As a statistician, we with the colleague of Terna are looking to increase the number of industries involved in this exercise, so for make this index more robust. And even if in the first period, during the first wave of the pandemic, this index was not released to the public, but used just for the government, for the high-level people of the Terna, or TSO, that are in charge of the management of the grid of electricity. After this first period, now the situation changed, and Terna starts to publish this information on the website, and we continue to elaborate this index and to share this information with all the analysts and all the citizens that are interested to take a look at this. And this is just because it was recognized that is a very useful index, simple information, simple index that can be understood by a lot of population, a lot of analysts. And that is what we put, and what we try to put at disposition of the government, of the analysts during the pandemics, and for give very fresh information on how the economy is going in Italy. We think that something of this can be easily elaborated in the other countries too, and this is why we're happy to share with you this information. Thanks for the attention.
Great, thank you very much. Gotta put myself back on video. Okay, sorry, for time management, we're gonna move on to the next presentation. Thank you, Giovanni. Next presentation is by Amar Amarnath from CAPSARC, Rethinking Data Collection and COVID-19 Crisis. And I'm letting time slip a little bit here, so I'll give you a heads up when there's a couple of minutes left in your presentation, okay? Amar, you good to go?
Awesome.
Okay,
hope you can hear me all right. I'll go ahead. CAPSARC might be new for several of you. Stands for King Abdullah Petroleum Studies and Research Center. And we can move on to the next slide. So I want to give a brief intro of what CAPSARC is. The agenda that I'm going to cover is going to be a little twist. I'm not going to talk about Saudi Arabia metrics and details and collections a lot. I'm going to talk about how we are trying to address the data problem from computing viewpoint. So I'll have a slide on data challenge, then I'll talk about how we are addressing it, and then some data quality and the models initiative that we have. and also the new data sets and the dashboards, given we don't have statistical official data coming in, how else we could compute for the research purposes. We move on to the next slide. So CAPSAR, we are around 80 researchers from 23 countries located here in Riyadh, in Saudi Arabia. We work at any given point of time 40-45 projects, as you see on the right side top, from various programs: climate, energy macroeconomics, energy transitions, which is essentially electricity consumption demand, market industrial development, urban infrastructure and transport. And I represent energy information management. I'm a parallel program which cuts through all of these initiatives from a data, model, and tools viewpoint. We can move on to the next. We are a non-profit energy think tank, and we advise and create the research that is consumed by the policy stakeholders in the region and worldwide. So let me anchor in data challenge, right? So we are a relatively newer institute. We are less than 10 years old. And with the 80 researchers trying to come up with policy pathways and models and insights, we needed a lot of data. Since we did not have history, we had to start off afresh. So some of the key challenges that we have is historical data is not readily available, and sectorial information doesn't exist, and you don't have a short span data, the recent data at a higher frequency. Those are the high. Anytime when we go back to data publishers and the statistical offices, most of the times we come back and explain what is the consequence if we don't have it. We can't model it right, we can't set up the linkages right, and we are unable to perform the policy analysis and projections right. The most reason given back is that, well, anonymity of the data and the confidentiality of the data. So, of course, there are several ways we could do the masking of the data by providing detail, but still the challenge there exists. So let me quickly talk about some of the energy-related numbers amid the COVID-19. Like if you look at, unlike in other countries, the drop in electricity consumption during the lockdown period is only 1.7%. When compared to European countries, 70%, you have heard about 20%, 30% numbers, but here it is less. That is primarily because of the uniqueness. 70%, right, of the residential and commercial use is for air conditioning. And 80% of Saudi electricity demand is for buildings, essentially cooling, right? So the warmer weather increases the electricity demand. And this happened during the summer, which is the warmer period between March and the August is the warmest period in Saudi Arabia. So obviously our energy consumption in a residential significantly increased, because the average household here in Saudi Arabia is 4.6, as compared to European countries, more like 2.3, right? So more people started staying home, so the electricity consumption at home increased significantly, even though some of the industrial and others have reduced. So the moral is that for different regions, we have different problems, and during COVID season, electricity demand reduction wasn't one of the problems, because the people consumed that because of the summer weather anyways outside. Irrespective, the bigger concern is that the average Saudi household consumes 17 megawatt hour of consumption, whereas the other countries, European, when you compare, 3.7. So we are 5 times more likely to more consumption rate there exists, just because of the weather where we are in, and the household size is bigger. So getting back to, we can move on to the next slide. So the way how we are trying to address in collection of this data is, first, we went ahead 4 years ago, we initiated a data portal program, whereas we create an open data set where 200 publishers in and around the region, and also some of the global data sets, we went and pulled them together to create a uniform looking, machine readable, application programming interface ready data sets that average information seeker, data seeker, be be a researcher, academia, or an industry that can consume. So this is one way for us to address, because in the Middle East, there weren't such open data sets that existed like EIA, IEA, and others where we could consume. So we focused on the regional publishers and tried to put together this data sets. We have around 80 million records, 1,400 data sets, classified into 16 themes. And as I said, around 200 publishers or so. Most of it is anchored on GCC countries, because that's where the open data wasn't easily available. So we move on to the next. So this is what you would find within the data portal. The data portal is built on a technology called Elasticsearch, very similar to Wikipedia, right? Wikipedia is built on Elasticsearch, and so does our data portal as well. So the data that represents, as you see, most of it is annual. 76% of the data sets we have is annual. We do have some daily, hourly data like the temperature, etc., but not huge and significant. But we are continuing to make sure we have a clean, machine-readable data all in one format where they don't have to even use our user interface. They can call it by a programmer using the APIs, and we provide an ability to search, filter, create charts, maps, create custom charts by the users on the portal so that they can improve the understanding of. Why do we have to do it? CapSARC is set up to be a platform for a dialogue to talk about energy opportunities and challenges. But if we can't keep our research objects, which is models and data sets and recipes, how we convert the statistical data into usable data into a model, all of that we want to make it open, and that's what we are working towards. We move on to the next slide. So here's one example, right? So we are Energy Economics Institute. The focus is to improve the understanding of energy. But the moment the COVID issue came in, the end of February, early March, we quickly realized that this would be one of the important data sets that everybody wanted to know, because so that we can find impacts on the energy and economics, etc. So we went to the Ministry of Health within Saudi Arabia and tried to mine their PDF documents, because initially that's how they started publishing the data, and started creating a machine-readable data that people can use it beyond the PDF documents. And later they caught up and they had, you know, granular data as well. But we right away started creating every event that happened, we tried to capture, be it lockdown, be it warnings, be it social distancing measures, that you see them, each one of them as the lines on the chart onto the left. So for on each of these events, how you know, the cases progressed. So we started tracking. Because of the data was readily available in the form of, and also we captured everything what we got from the source link, cross-reference, so that if they don't want to use that data, they can go to the source and get it from PDF documents. And we have the table views where you can filter, just like Excel, and then you can analyze, have the dashboards ready in. So this particular data set was the most popular, needless to say, this year. Over 66,000 times it has been downloaded, and there's a lot of good coverage. So this is one way for us to adjust how do we collect the data that is most useful for energy economics community. And the second, what we did was Google mobility data, as well as the Apple you know, map mobility data. We started consuming that data and start producing data that is detailed enough for the researchers so that they can go and publish their publications. So we created around 9 publications in the 3 to 4 month period on COVID-19 impact to Saudi Arabia primarily and the neighboring regions, using the data, mostly got it through this kind of means, which is an approximation, not a statistically you know, official data, but still using, you know, that's one of the new ways where we could mine a lot of data using, and thankfully Google started publishing their mobility data by region, by area, by city on a 1 day to 2 day delay. That's a lot more granular and timeliness data that we could expect, and that was very useful for the research. We can move to the next slide.
I'm sorry, Amar, I'm sorry to interrupt, but if you could wrap up the next 2 minutes, please.
Okay, will do. We can move to the next slide. Likewise, we created around 46 dashboards just to monitor every single indicator within energy economics from a C19 lens. All of this is open. Nobody has to log in. We have this information. We move to the next slide. We can move on to the next. So I want to cover, next slide, please. So we have created around 14 publicly available tools on our website. As you look at, there is one tool on the left you see is the building efficiency tool, where it is built on the DOE engine from US, where an average builder or a contractor could go and put in the spec of the building they are putting in, and it'll tell whether it meets the Saudi Arabian building standard code yes or no. Or we have the input output. If there is an impact to one sector because of COVID, what will be the spillover impact to the other sector that you see on the right side top. So there are a bunch of tools there exist, and we are trying to upgrade our technology. There are 3 million smart meters are being installed in Saudi Arabia. Now we are already working with tools from Amazon and other technologies to consume that data and provide some timely insights to the researcher. So that's all I had to say. There are more slides along with this. You can go check it out. That I list the architecture of our data consumption, analysis, and policy insights and policy model. We have open source tools, both for the data portal as well as the modelers. Modelers can maintain their versions of the data. So please go and check out. You just go to Google, search for Open Capsar. You should be able to find our open source tools that you could use. Thank you.
Great. Thank you very much. Greatly appreciate it. Okay, we'll move on to the next presentation. Arijit Singapta from India. Overview from BEE, data and impacts from COVID-19. Arijit, are you okay to go?
Yeah.
Okay, you're up. Thank you very much.
Yeah, thank you, Bob, and thank you, IEA, EEUDEEM, and Office of Energy Efficiency Canada for providing the Bureau of Energy Efficiency, Government of India, with this opportunity to share our thoughts and views on this important topic of data and metrics. Can we move on to the next slide, please? Yeah. So before I go into the various facts and figures which are represented in this slide, I would like to highlight a few things. Of course, the Bureau of Energy Efficiency was established in 2001 as part of the Energy Conservation Act, and the major mandates, if I refer to, that was provided in the Act was in the areas of building energy efficiency, appliance energy efficiency, and industrial energy efficiency. Of course, we do work in other sectors as well. Most majorly, if I refer to in the last couple of years, we actively engage ourselves in the transport sector as well. We are, of course, collecting a lot of data, but however, as far as the analysis of data is concerned, we are still kind of trying to learn the best practices from others and trying to devise our own methodology. If we look at the Indian scenario, we have a very good kind of data indicators available on the supply side. However, if we look at the demand side, and if we look at all the demand side sectors, be it industries, be it commercial buildings, be it appliances, be it transport, we don't have a very rich set of data. Although we have some data at the national level, but if we look at the local level or at the state level, we really lack, some rich quality of data availability. And that is where I think the mandate of Bureau of Energy Efficiency perfectly fits it. So we have started, as I mentioned, collection of data, and based on the analysis which we have made, we have seen that in 2018-19, we could save around 140 billion units of electrical energy, and around 12 million tons of oil equivalent of thermal energy. Now, as far as this electrical energy efficiency is concerned, the major contribution to this is one of course, our appliances scheme, the standards and labeling of appliances, and the Ujala scheme, wherein we were providing LED bulbs to the domestic consumers. And as far as the thermal savings are concerned, the major contributor to this is the Perform, Achieve and Trade scheme, wherein we have been assigning some specific energy consumption reduction targets to large energy intensive industries, and we are monitoring the achievements after every 3 years. So we have a very robust monitoring scheme in place. Now, as far as the total emission reduction is concerned, it is of course around more than 150 million tons of CO2, and the total energy savings, that is 24.08, is approximately around 2.7% of the total primary energy supply of the country. Next, please. So these are the various schemes and the programs which have been considered while we have come up with this kind of savings, which I've showed in the earlier slide. Of course, I'm not going to go into the details of each of these schemes, but it kind of encapsulate all the schemes which are currently ongoing in our country to promote energy efficiency, and we are analyzing all these schemes. Next, please. This is the data collection approach which we have followed. So we do a lot of stakeholder consultation. So as you can see, we are doing a lot of stakeholder consultation with various organizations, various departments, various ministries of the government. And then we have a methodology through which we collect scheme specific data. So you can see, I mean, in front of each of these organizations, we have tried to map the kind of data which we are collecting from each of these organizations. And as far as the data which we analyze electricity savings, in terms of electrical energy, in terms of thermal energy, and then you convert these savings in terms of monetary terms, and also in CO2 reduction terms. Next, please. So this is the approach we have. We have a very rich, as I mentioned, data collection. We have a data source as far as the appliances sector and the industry sector is concerned. In fact, one of my colleagues, Ms. Vinita Kanwal, who is again a participant to this workshop, is responsible for development of this PADNet portal for industry. So we do have a very rich source of data that comes into these portals, especially the industry and the appliances. But again, I think some of my previous speakers have also mentioned that there is a confidentiality clause that we normally have with the manufacturers as far as the appliance is concerned, with the energy intensive industries as far as the PADNet portal is concerned. So we are unable to kind of come up with a publicly with all the data, but we are trying to find out how best within the kind of the issues that we have, how best we can analyze those data and by masking some of the names or whatever it is. And we are in the process of developing this EMIS for buildings and the SMEs energy mapping. Next, please. So this is a slide I have tried to capture and when I'm trying to highlight the kind of impact that the COVID-19 has had on the data collection approach that the Bureau of Energy Efficiency has. So we, for example, as far as the industrial energy efficiency scheme of the perform, achieve and trade, which I have explained a bit earlier also. So we normally ask all the energy intensive industries, which we refer to as the designated consumers, to submit their form and the energy consumption returns by a stipulated time frame. But due to the COVID-19, this had to be extended. That was mainly because of the fact that they were not coming to the office and they have to upload some of their forms. Similarly, we have a rolling cycle for the perform, achieve and trade scheme for the industries. Again, as I mentioned, we have a very robust mechanism in place, and insofar as the monitoring and the verification of that scheme is concerned, but that also had to be extended because of this global pandemic. And as far as the impact in appliances sector is concerned, we have this portal for wherein we are collecting data from all the manufacturers for the appliances which are covered under the standards and labeling scheme. However, this was again, kind of extended on a case-to-case basis for each of the appliances. Next, please. So this is the way forward, or as I mentioned, we do have a kind of a platform where we are collecting lots of data. But as far as analyzing those data and coming up with kind of good representative things are concerned, we are still in the process of developing. But we have recently developed this Urja Dakshata information tool, of course, which is going to be in the public domain very soon. We are actually migrating it from a private data source to a kind of a government database. That is why it is taking some time. But this is how it looks like. It is, of course, a representative picture which we are showing here. So this is how it looks like. And if you click to each of these buttons, you will be able to understand what kind of data is happening and what is happening state-wise also. But if, for example, if we go to the industry, we will be able to learn how the industries are featuring in each state. So that kind of data we are trying to capture through the rich database that we have. Next, please.
Sorry to interrupt. My apologies. If you could wrap up the next 2 minutes, please.
Okay, thanks. So, of course, I have only a couple of slides more. So this is we have also kind of carried out a study to estimate the savings potential. And we have prepared a strategic plan. And this is what the sector-wise savings potential is concerned. This is something which we have done by following a robust bottom-up approach methodology. And we have also prepared some model. Of course, the model is based on an Excel tool. So, but that was what we did with whatever limitation we had. And this is how the outcome looks like. Next, please. This is the last slide. So the various economic recovery options which we have tried to come up with in view of the global pandemic. Of course, we have kind of segregated it into 4 parts. Number 1 is focusing on the appliances sector, wherein we are trying to promote more indigenous manufacturing. And secondly, it is about how to generate more jobs. So we are promoting a sector that is a cold chain, which is the agriculture sector and is the kind of a backbone of our country. And it contributes almost 17% to the GDP of our country. The third is, of course, the technology replacement part, how to stimulate the MSMEs. And fourthly, it is the buildings. And because we know that, I mean, buildings has a lot of potential as far as job generation is concerned. And next, please. So this is all what I had to say. Thank you very much for your patient hearing.
Thank you very much. Very interesting. We'll move on to the last presentation. Didier Baspoff from France. Didier, are you good to go?
Normally, I have opened everything.
Okay. Great.
Okay,
please go ahead.
So I'm from EEUDEEM, the French Agency for Efficiency, which implement energy efficiency policy. I am in charge of monitoring all these energy efficiency policies at French level and at European level. Next. My presentation will be shortened. I will show some insight about how the current data collection on end-use data has been affected by the COVID. And then I will show you a methodology that we will implement at EU level on how to obtain, let's say, T-1 data from EU data. Next. So we have, of course, different situation. The end-use survey that was launched before March. March was a time when the pandemic come to France and when we have a lockdown. So all these surveys which were launched before were not affected. Obviously, the main surveys which have been affected by the crisis are those we rely on a face-to-face methodology. We have for each sector, mainly in industry and in household, transportation, face-to-face surveys. And of course, some has been postponed, some has been put on, transferred as a phone-based survey. And one of the reasons is that the surveyors do not want to make the face-to-face survey to preserve their health. And also, at that time, let's say the mind of the French was not to answer to surveys. And we believe that we will have bad welcoming from the surveyors. However, from our statistical office has postponed his household panel until September. So you will see in general we have delays in our main end-use surveys. What is important for the future, I think it's we have observed that all our phone-based survey has been not damaged by the COVID pandemic, except that the response rate was lower. For example, we have a 100,000, there is 10 too much, 100,000 survey on private household. Normally the response rate is 80% and we have a 50% response rate. For the service sector, which was mainly by email, and we have also less answer by mail, so we have both mail and email, and of course the response rate has dropped dramatically. So we compensate that by a hotline service to push again the companies to answer to our end-use survey. It was a good business for private sector. A lot of private office has oriented some of their surveys to COVID issue. For example, impact on health, impact on employment. So I may say it's a good business for statisticians right now. There are also surveys by the public sector, like IEEDEEM, like the ministry, or like the statistical office. And in general, we can say this end-use survey has been postponed or modified. And in particular, we have different surveys on employment, on industry, on health, on household behavior. So they are not directly energy surveys, but they are surveys which help us to understand the drivers of energy. We have also some surveys for electricity, and the electric utilities make surveys on how the COVID has impacted electricity use from their customers. So it's more or less what our colleague Giovanni present, more or less. So what is interesting, it's as a sort of mini conclusion, COVID has pushed data collection in a hurry. You know that IEA likes this word, electricity in a hurry, etc. So in fact, it pushed the statistician to use new type of, let's say, data collection methodology. So we will use more GPS, credit card, Google Trends, etc. Materials instead of classic face-to-face or email survey. So in one way, we will have delay in all end users data, but we have developed new methodologies which can be interesting insight for the future. Next one. Next one, please. Yes, thank you. So why we have implemented early estimate at European level. If you remember the presentation of Canada, they present some decomposition analysis in 2018. And generally, we have the energy balance in -1, T-1, but the end-use survey provide data in T-2. And then when we calculate savings based on this survey, we have 2 years delay, which is not good when a minister wants to present impact of their energy efficiency plan or recovery plan. So this is, and generally they use energy intensity that can be easily estimated and very rapidly, let's say T-1. But this indicator, energy intensity, it's a very weak proxy of energy efficiency, and it's shared among all the analysts. This is why we have developed a methodology able to provide advanced energy indicators at T-1. For example, on energy efficiency index improvement, energy saving, and decomposition analysis. Next. This methodology depends on the sector, and I will illustrate, depend on my time, on one or two sectors. And to do this early estimate, we need macro data like population, GDP by sector, primary energy, which are available at T-1. We need final consumption by main sector, which is also available at T-1 through the energy balance. And we need sectoral economic drivers like stock of activity data, stock of vehicle traffic, production index, as it was shown by Giovanni for Italy. Next one. So you have here example of this early estimate. So you see the official data is until 2018 for this energy efficiency index based on 50 physical indicators. And with our estimate, we were able to prolong of 1 year the estimate. And you see that there is a slightly faster improvement from 2018 to 2018 compared to the previous year. On the graph below, you can see that we were able to make a decomposition analysis of any final energy consumption for EU from 2014 to 2019. So this is a type of product that we can produce now in T-1 using our methodology. Next one. This is another way to present that. We have a target to 2020, and you see that we were able to prolong the energy efficiency and the final consumption and to see if we are close to the target or not. So we win, let's say, 1 year in our diagnosis if we are able to track the target, to reach the target. Next one. So this is concrete result where we have applied that method. So to do that, this let's say methodological part will illustrate for industry, and it's very complementary to what my friend Giovanni present. We have to evaluate the energy consumption by branch, and it estimates based on industrial production index. It's very available every month, very rapidly, and physical production, especially for energy intensive industry like steel, cement, pulp and paper, and so on. And the methodology is the following. For each branch, let's say chemical, steel, textile, etc., we calculate a consumption at constant specific consumption, and it's based on the production level that we got at T-1 and the specific consumption at T-2. So we use a frozen unit consumption. So it's a fictive consumption by branch. And we calculate the same for the wool industry as the sum of the branch. And we compare this fictive consumption to the T-1 consumption of industry, which comes from the energy balance. And we scale this, our assumption at T-1 by branch based on this total. So, in fact, we are able to take into account the structural change between T-1 and T-2, which can be observed in the industry sector. And we include energy efficiency trend, but the drawback of that methodology is the improvement of efficiency. It's the same for all the industrial branches. It's an assumption. Next.
Didier, my apologies, but if you could wrap up in the next couple of minutes, please.
Yes, so you will see in my presentation that we developed the same methodologies for households and for transportation. They will be available in the presentation. It's the same principle, but for we separate electricity and fuel. And the idea is to develop to assess the stock of appliances, for instance, based on the stock of T-2 with the new registration, the new sales. So we are able to calculate stock of electrical appliance at T-2. And then with a combination of, let's say, energy data and activity data, we will be able to evaluate the consumption by electrical appliance for T-1. So you see the advantage of that methodology for dissemination and communication of our result. We are able to evaluate the energy saving and all this advanced analysis for T-1 instead of T-2. And you understand why it's important for the minister, for the government to have a more rapid appraisal. So we are implementing that at the European level through the Odyssey project. So next time I can present the result for 30 countries. Thank you for attention.
Thank you very much. Appreciate the presentation.